be like?
Yeah,
Now it is.
45. No.
the way we start this,
High school, you got
there's
that.
no new information. It's just learning how to do these kinds of problems. So I will do examples for you very slowly. And then we'll do another example very slowly. And then we'll do another example very slowly. And hopefully you start to catch on. When you hear the word rate, what do you think of mathematically? Change. Which?
I think of derivative.
Derivatives.
Did you
Nice.
tell us that one time?
Yeah, probably.
Nada.
So this is going to be a challenge because I don't even know if I remember how to do these problems. So just kind of winging it here. Oh, this is already recording.
Yep. No.
It was just like before your chapter 5 test, I made a big old long video of doing the homework. And usually I like at least look at the answers or read the problems before I start filming. I was just like, oh, film. Here we go. This is just me doing the problems straight up. It was fun. It's a good time. No one watched it.
No, we did.
Yeah, we all did.
I don't know what you say when you don't watch it.
There's like 4 views on that one.
We were in Spain before that. I saw it and I just didn't even lie.
It was very long.
So
It's like an
that's
hour.
Yeah.
It was before we left.
Okay, really, number 1. I think that's a good place to start.
I don't think I watched it.
Yeah, start with the first one you give you. Like it.
How fast is the area of a square increasing at the instant when the sides are 4 feet long if the sides increase at a rate of 1.5 feet per minute?
Is this where you plug in the like
Oh my god.
radius and then you plug in what it changes from?
Kind of like that, but now there
Didn't we? You
Like
give
the
us
story
one of
problem?
these
are
on a
2
circle?
things that are changing. All of these problems will have 2 things that are changing. Related rates. There's 2 rates happening and they're related to each other, right?
The one
Is this
changes
like that
makes the other
circle
change.
problem on the chapter test?
Kind of. But on all of those, only one thing was changing. It was like, how fast is the area changing if the radius is changing at a rate of... Those are not related rates. They're almost related rates, but only one thing's
Well, I
changing.
don't even know how to do
Here we go.
So there we go. Let's just go number 1 here. I read the question. How fast is a square? I'm going to draw a square just because I like to draw pictures.
that.
You sound like
We did math on whiteboards for 3 hours.
How fast is the area of a square? Ooh, when I think area of a square,
rate times width or x squared.
yeah, isn't it just area would be x squared, right? You know what I'm saying? Okay, what are we trying to find? How fast is the area increasing? At the instant when the sides are 4 feet long,
The
the
max.
sides increase at a rate of 1.5 feet per minute. So there are actually kind of like 3 things that are changing here. The area is changing, right?
Well, the area changes, the sides change,
The sides change,
and then you're changing.
and
the-
time is moving because we have time that goes on, right? So what we're going to do, when it says find how fast the area of the square is increasing, that's like dA, right?
The derivative of area.
The derivative of the area. So we're finding dA with respect to time now. So that'd be dA dt. We're finding how the area changes over time. We're not doing this. Do you understand the difference between that and that?
You're finding the side versus finding the time.
This would be how the area changes over time. This is how the area changes as the sides change. We don't want this one. We want the area changing over time. So we're going to find that when it says at the instant when the sides are 4 feet long. So don't we know x?
Yes.
X is 4. If the sides increase at a rate of 1.5 feet per minute.
So it would be 5.5? Or no?
No. If the sides are increasing, isn't that the rate of change of the sides? So that's dx dt is 1.5 feet per minute. It's the change in the sides over time, right? They change 1.5 feet every minute. So now what we do is do the derivative.
Okay.
Huh?
10%.
10%? Oh, we're good. Now what we do is do the derivative of that with respect to time, and it's really just the derivative of the a is just going to be, oops, too many squiggles. dA dt. That's it. And when you do the derivative of this side,
It'd be 2x
2x
dx
dx over
dt.
dt. Plug in what we know, solve for what we don't. That's it.
She's like
Why do you
21.
put it over DT?
Because we're doing it with respect to time.
Okay.
Dude, my sister got married 4 months out of high school and had a kid like 6 months later. Okay, that makes sense.
Megan. She's like 20.
That's cool.
She's a really small person.
Yeah, she is.
She's 5'4", like 100 pounds.
It's 8 times 1.5, 12. What are our units? Gotta have units.
Feet per minute.
You could get your units by looking at this.
I what?
This. If you know the units for area. Or we can get our units by looking at these numbers and actually writing our units. When we put in 4, isn't that 4 feet? And when I put in 1.5, wasn't that feet per minute?
So is it feet
So if
squared?
I multiply those, what do I get?
Feet squared per minute? That's weird.
Here, area is feet squared. In this case, time is minutes, feet squared per minute. Look there.
That makes sense.
Woo! That's it. I feel like this is easy.
Ah,
You're fine.
Not too bad.
What's the next two problems?
Let's do number 2.
Is it worse?
It's gonna get worse.
Of course they get
I
worse.
still don't
I
know.
don't like it.
Huh?
I still don't know what happened.
We'll just have it. Suppose z equals y to the 4th, x to the 3rd. Now we have at the instant when x equals 1 and y equals 3. X is decreasing, so when we have x equal to 1, y equal to 3, x is decreasing at 2 units per second. What do you think that tells us?
That is our dx over dt.
It's the change in x with respect to time, right? We look at the units. It's changing at 2. It's decreasing at 2 units per second. So what are we going to put here? I would put -2.
Oh, that's what decreasing means.
Yeah. Units per second. Whatever our units are, who cares? It says at the instant when x equals 1 and y equals 3, x is decreasing at 2 units per second. Y is increasing at 2 units per second. What does that tell you?
That y is positive.
dy dt. It's telling you the change. Change in y over time, right? That's what that means. Another way of reading that. Change in y with respect to time is increasing it. So it's 2 units per second. How fast is z changing at this instant? What do you think we're going to do?
Find the derivative of the original.
Find the derivative of the original, plug in what we know, solve for what we don't. Okay, now the challenging part is doing the derivatives of the original. With respect to time. So what's the derivative of z?
dz over dt, yes.
What's the derivative of the right side? Product rule.
Oh, obstacle strings.
No.
Crowd goes. It's a freaking product rule. It's easy. First one times the derivative of the second time plus second one times the derivative of the first.
I think it'll take a little.
Try it.
Say that again? You went
I just
fast.
first one times the derivative of the second plus second one times the derivative of the first.
So if you keep it the same though, you don't do the dy.
That's what you should start with.
So the second part is x to the third 4y squared cubed dy over dt.
Plug in the stuff you know, and you'll be done. You negative 270?
I didn't get that far. I just finished putting everything in the right order.
I think it's negative 270.
No, it's positive. Oh wait. 81. Yeah, it's negative 270. Sorry, Doc.
Plugging in all the numbers. Negative 270. And then I'd ask, where to go?
Is it
Is
decreasing?
Z increasing or decreasing?
Decreasing.
Yeah, it's Number 3. Yeah, it's just a number plug-in error. Pretty messy. Oh, it's in here good now. Let theta be the acute angle of a right triangle with legs of length x and y. Ooh, I see a picture there.
Do a right triangle.
An acute angle of a, so draw a right triangle. Doesn't matter how you draw it.
And put beta in a Q angle.
But theta is one of the angles. The legs are x and y. That's my picture I see. You want to try to set this one up on your own? Or at least just write the information down that it says in words and write it down on your paper? Let's try that one. It says at a certain instant, x equals 4.
So this is all over time, right? Everything is usually time.
At a certain instant, x equals 4, and then x is increasing at 2 units per second, while y equals 3 and is decreasing at half a unit per second. So just try to write that information down on your paper.
We're gonna have to use like sine and cosine, huh?
Get those? X equals 4, dx dt is 2, y equals 3, dy dt is negative half. Okay. Ready? How fast is theta changing at that instant? Oh, so we're going to try to find d theta dt. But before we do that, we better write an equation relating theta with x and y.
I forgot.
Now, you may not know the unit circle, but I hope you can do this. Can you write an equation that relates theta to x and y? Sokotoa.
It's tangent, right?
Tangent of theta.
Equals y over x.
Yeah. Tangent of
I don't even
theta is
remember
y
how that
over
even makes
x.
sense, but-
Yes.
I just tell what opposite of it is.
It'll make our lives much easier if we have theta equals, that when we do the derivative, won't it already be d theta dt equals, and then we don't have to solve for anything?
So you have y over x.
So how do you solve for theta in that equation?
Plug in y and.
No.
No, divide,
By-
no, multiply by x and divide by tangent.
That's what the other side.
Multiply by x.
Oh, divide by tangent.
You sound like
Multiply
first semester geometry
by
students.
10.
Dude, that's what we used to do.
Isn't that what we're supposed to do?
Multiply.
Do the inverse.
Inverse tangent.
Huh?
You can't divide by tangent. Tangent.
That's
This
what
is
you
a-
did, we did in geometry.
No way.
Yeah,
Absolutely
way.
not. No.
Oh,
Oh, we did
Baloney.
the inverse and then you would figure it
Baloney.
out.
You did this.
We
You
can
did.
see.
Are we going back 4 years?
We can't see.
If you were doing this, you would have tangent of 20 equals 3 over x, multiplied by x, divide by the tangent of 20,
From 3.
which is a number.
Oh, and then we would solve.
And
So
then you
x would equal 3
okay.
divided by the tangent of 20. You never divided by tangent in order to solve for the thing.
Okay, we turn it into
To
inverse.
do that, you would use the inverse tangent, because that is the opposite of tangent.
I was getting-
Theta would equal the inverse tangent of y over x.
Yes, we need to.
They have their student preview.
Now the fun part,
Which
Wait,
The inverse of tangent is, do we want
the
that?
derivative.
1 over 1 plus x squared.
Yep. So we do the derivative of both sides. D theta dt equals, what was it, 1 over 1 plus x squared, right?
Yes.
Yes.
So it's 1 over 1 plus the thing in the
Y plus x,
parentheses.
y over x squared.
Yeah, that's
Y
it.
over x squared. Anything else?
No.
Times
D.
the derivative of the thing in the parentheses,
Which is quotient rule.
which is quotient
That's
rule.
easy though, because it's 1. Oh, that's stupid.
Try it. Try to do quotient rule there. That'll go here.
Oh my gosh, I always forget to write that.
Low D high minus high D low over low squared. There it is. Low D high minus high D low.
So that basically just goes on the top, right?
That's this whole thing multiplied by this whole thing.
Oh no, because the bottom.
Now just plug in the crap you have. So we're going to have 1 over 1 plus y over x is 3/4 squared.
It was yours, and I know.
times
4 times 2 minus
4 times negative half. Be careful.
What's your supposed to get?
Oh, it's
X, dy, dt.
dy.
Why?
Because the
Oh,
low.
derivative, it's, okay.
Yeah.
I know, I know. Shut up, bitch.
Get that big old ugly thing.
Really, just a calculator?
Yeah, do that.
What?
Watch, you just go 3/4 squared is 9
I
16ths.
was.
9 16ths plus 16 16ths, 25 16ths. Well, 1 over that, with the multiply, so that side, that's 16 25ths. Times whatever this means. 4 times
Wait, what?
Wow.
How could you flip
3/4 is 9 16ths. What? 3/4 squared 9 16ths.
You have negative 8/6 on your side?
This is a negative 2
8/16, that's what I meant.
minus 8 minus 6. Negative 2 minus 6 is negative 8 16ths,
So you have 16.
which is just negative a half.
Times negative.
So I get negative 16 50ths, which is negative 8 25ths.
And can't go anymore. Sorry
And
about it.
that's it, and that's your answer. Radians per second.
That kind of sucks.
Why radians? Because it's beta?
Because
When you
Because
use
it's
like
the-
cosine, tangent models, it's
it's
radians.
gonna be in radians most of the time.
Let's look at my whole page.
Yep. I'll show you one
Oh, I
more,
did it already.
and you can do the last 5.
For homework?
Yeah.
Oh, we already on this. He already-
Here's the number 4. I'll try to make you do each step on your own. First step is always draw a picture if there's one to be drawn. Assume that oil spilled from a ruptured tanker spreads in a circular pattern whose radius increases at a constant rate of 2 feet per
So
second.
it's a circle.
It's a circle.
You see, I'm gonna have a hard time with that part. That's like, the rest are okay. but
Just,
that part's
it's
like-
it's an oil spill that's a circle.
Oh my gosh, it's a circle.
What's happening to the circle?
It is increasing.
The radius is
Getting
in,
bigger.
so it's just getting bigger. It's like, whoosh, yeah, it's going out. Okay, just a little visual. You don't have to have that. Okay. See if you can just read it, write down the information it tells you, and then write the equation whose derivative you're going to find. Try it or no.
Wait, what? Sorry.
Write down the stuff it tells you, like the x's and the y's and the dx's and the dy's. And then try to write the equation you're going to use to find the derivative and plug in the stuff.
No, I haven't memorized it. Is that sig pi squared? I'm asking her to look at it.
I can't see either.
I have it written down, but I'm
Yeah,
gonna
get
try
rid of
it.
that.
Is it pi squared?
It is pi squared.
Just checking. Jeez.
Done, Heidi? Let's tell you. What's one thing it tells you? What's one thing you wrote down?
The radius increases at a constant rate of 2 feet per second.
That's what you wrote on the paper?
Yeah.
Okay, what'd you write on the paper from that sentence?
Oh, I didn't really know like the units. I was right.
Units.
dr or dt equals 2 feet per second.
Yep. When it talks about the rate something happens, that's that. It's the respect to time right there. So radius increases at a constant rate of 2 feet per second.
So we're trying to find.
So what are we trying to find?
The area.
How fast is the area increasing? So that'd be dA dt.
Oh, good.
When, so basically, I like to write this, just, I know, I'm going to find dA dt when
R equals 60.
r equals 60. Can you write the equation, do the derivative, plug in the stuff you know, and give me the answer?
Whoa, slow down.
Is that when you use pi r squared?
Yeah, isn't the area of a circle pi r squared?
Yes.
Do the derivative of both sides, plug in the stuff you know, and you'll have the answer.
Do you know the answer?
Yes.
Is it a big number?
8 is relative.
Yeah.
5?
Yeah.
Okay.
I don't know.
Did you do area equals pi r squared?
Did I do what?
dA
Oh, dA?
over dt.
Do the derivative of the area equation. Make sure you have your dA dt, your dr dt.
You just told me.
753.9.
Well, when you do the derivative of the right side, so area equals pi r squared, correct? That's the derivative of the left side.
dA over dt.
What do you mean left side?
Of the equal sign?
Oh.
Let's do the derivative of this,
2 pi r.
Yes.
2 pi r
dr.
dr dt.
Yeah.
Yeah,
That's it.
Wow. Hey, not too bad.
And you just plug it in.
And then just plug in the stuff they gave you.
2 pi times
60 times 2. 60 times 2 Am I stupid or something?
both.
You should just get
Every time
245.
someone outside.
140 pi? Okay, I'm not stupid or dumb, should I?
240 pi feet squared per second.
What the heck were you guys talking starts with a 7?
If you multiply 240 times pi, you get 753.9.
I was gonna say, why didn't you get that? But never mind.
You do.
Not here.
No, which dog key?
She is something else.
I would like to see you attempt
Now,
the next 5 problems,
For homework? Starting now?
starting now. Notice on number 5, they give you the volume for a sphere.
I was gonna say.
It's at the end.
Squigger?
So, Viper.
can we stop this?
Yeah, you can stop. Here are the problems on the worksheet. I don't know why it won't film the other way. You're gonna have to probably like,
I won't get it in state tuition until like.
hopefully you can see that
So
and
before I
pause
multiply, I can divide by dy dt, right?